Hello and welcome to today's episode of Eco Innovations, and today, we have something truly exciting to talk about: biogas production. It's a process that not only helps us manage waste, but also plays a huge role in sustainable energy. We will be discussing the factors that affects biogas production. Stay tuned.
Joining me today is technologist Samuel, an expert in renewable energy, here to break down the science behind biogas and share what factors influence its production. Welcome, technologist Samuel, we're so glad to have you.
Thanks for having me. I'm really excited to be here and talk about biogas. It's a field with so much potential, and I think your viewers will really enjoy learning about it.
Alright, before we dive into the nitty-gritty, let's get the basics down. What exactly is biogas, and why is it becoming such an important part of the renewable energy conversation?
Biogas is a renewable energy source that comes from the breakdown of organic materials like food waste, agricultural residues, or even animal manure, in an anaerobic environment, meaning without oxygen. This process produces a gas, mostly methane, which is an excellent fuel for generating electricity, heating, and even as a biofuel for vehicles. It's a powerful tool for reducing greenhouse gases, managing waste, and producing clean energy, which is why it's gaining so much attention these days.
Wow, it sounds like biogas is a win-win. Waste reduction and clean energy all wrapped into one. So, what are the key factors that determine how much biogas we can actually produce from this process?
Well, there are a number of factors that influence biogas production. Let's break them down one by one.
Great! What's the first factor we should know about?
First up is substrate quality. This is one of the most important factors. The type of organic waste you use directly impacts the amount of biogas you can produce. For example, food waste and manure are rich in sugars, proteins, and other simple compounds that are easily broken down by the microbes that produce biogas. But tougher, more fibrous materials like straw or wood take longer to decompose and require more effort.
So, in simple terms, not all waste is the same when it comes to producing biogas?
Exactly. You could say some waste is more biogas friendly than others.
What's the next factor that plays a big role?
Temperature is a huge one. Biogas production happens best in a temperature range between 35 to 40 degrees Celsius. This is called the mesophilic range. If the temperature is too low, the microbes responsible for breaking down the organic material slow down. If it gets too hot, those microbes can die off, and you lose production. So, it's like creating the perfect environment for these little microorganisms to thrive.
Ah, so the temperature needs to be just right, almost like Goldilocks for microbes. What about pH balance?
Great point. pH balance is another critical factor. For optimal biogas production, the pH needs to be slightly acidic to neutral, around 6.5 to 7.5. If the pH goes too high or too low, it can hinder microbial activity. So, if the system becomes too acidic, the microbes can't function properly, which impacts the whole biogas production process.
Got it. pH balance is key. Now, you also mentioned retention time earlier. What does that mean in the context of biogas?
Retention time is the amount of time organic material spends in the digester. The longer the material stays in, the more time microbes have to break it down, and the more biogas you'll produce. But here's the catch. It's all about balance. If the retention time is too long, the system could become inefficient, and other problems can arise, like unwanted compounds building up.
Sounds like there's a fine line between too much and too little. What's the next factor?
The next factor is mixing. Proper mixing is essential because it ensures that the organic materials are evenly distributed and that microbes can break down the material efficiently. If the waste material forms a crust or settles at the bottom, some of the microbes won't get the nutrients they need, and the biogas production drops.
So it's basically like stirring a pot. You want everything to be well mixed for optimal results.
Exactly. Think of it as the smoothie effect. Everything needs to blend together for the best outcome.
Last but not least, you mentioned nutrients earlier. Can you explain how that factors into the process?
Sure. Microbes require certain nutrients, like nitrogen, phosphorus, and trace elements, to function properly. In some cases, These nutrients need to be added to the digester to make sure the microbial community is healthy. It's like feeding the little guys what they need to do their job.
Now that we know what factors are at play, what are some of the biggest challenges in biogas production?
One challenge is feedstock inconsistency. The type and quality of organic material can vary significantly, and that can affect biogas yields. If the quality of feedstock is inconsistent, it becomes harder to predict and maintain stable production.
Got it. What's another challenge?
Another challenge is scaling up production. What works well on a small scale might not be as efficient on a larger scale. Larger systems require more complex management and infrastructure, and scaling up can introduce issues like system stability and cost.
I see. And I'm sure cost is always a concern, right?
Definitely. While biogas is a renewable energy source, setting up the infrastructure can be expensive. It's an upfront investment, but over time, it can become cost-effective. The key is finding the right balance between investment and return.
This has been so informative. Where do you see biogas production heading in the future? Are there any innovations on the horizon?
The future of biogas is bright. As technology advances, we're going to see improvements in efficiency and scalability. New methods for pre-treating organic materials, more robust microbial strains, and better monitoring systems will make biogas production more cost-effective and widespread. In the next decade, I believe biogas will play an even larger role in the global renewable energy mix.
Thank you so much, technologist Samuel, for sharing your expertise with us today. We've learned so much about biogas and the science behind it, and I'm sure our viewers have gained a whole new appreciation for this powerful renewable energy source.
It was my pleasure. I hope this conversation inspires people to explore biogas and maybe even get involved in the renewable energy field. It's an exciting area with so much potential.